Welcome to this explainer. Today, we're going to decode one of the most complex, geographically fragmented, and strategically crucial industries on the planet. We're talking, of course, about the global semiconductor ecosystem, and more specifically, India's highly strategic and, honestly, sometimes misunderstood integration into it. If you've been following the global chip race, you know exactly how high the stakes are right now. So we're cutting through the noise today to show you exactly how this massive global puzzle fits together. Here is our roadmap for today. We'll start with a macro view of the global chip ecosystem and its major power players. And then we'll zoom all the way in on India's strong starting point, their massive infrastructure push, and their step-by-step strategic master plan. All right, let's jump right into our first section and look at just how deeply fragmented the modern semiconductor industry really is. Think about the actual journey of a modern chip. It literally crosses multiple borders. It might be designed in the US, using intellectual property from the UK and software from American companies. The equipment used to make it, that comes from the Netherlands, Japan, and the US. The actual physical fabrication usually happens in Taiwan, maybe utilizing high-bandwidth memory from South Korea. From there, it's shipped to Southeast Asia for packaging, and finally, it's incorporated into the electronic device you buy in India or China. So this industry is absolutely not a monolith. It's a highly specialized global ecosystem. To really understand where a country like India fits into all this, we first need to map out who actually holds the power today. This matrix brilliantly breaks down how specialized every nation is. You've got the US absolutely dominating the highest value intellectual layers like chip design and software. Taiwan, obviously, is the undisputed king of advanced fabrication. South Korea rules the memory sector, dominating things like DRAM and NAND storage. And we can't forget Japan. They're kind of the invisible powerhouse here, supplying the vital upstream materials, silicon wafers, and specialty chemicals that literally make the whole operation possible. Now, because this system is so specialized, it creates some extreme bottlenecks. To put that into perspective, just think about the number 48. In all of 2025, the Netherlands-based company ASML sold just 48 of their EUV lithography systems. We're talking about machines the size of a public bus that print features almost at the atomic scale. They're absolutely critical for making today's most advanced chips. It just goes to show that the equipment ecosystem can be just as exclusive and strategic as the fabrication plants themselves. Meanwhile, we have to talk about China. China is the undeniable capacity giant right now, projected to hit over 10 million wafers per month in 2025. That's almost a third of the entire world's capacity. But there's a massive distinction we need to make here. Raw capacity does not equal technological leadership. They have enormous domestic demand for mature node chips, sure, but they remain heavily constrained in getting their hands on the most advanced equipment, like those giant ASML machines we just talked about. Because of these rigid bottlenecks at the absolute leading edge of fabrication, the battleground is actually shifting. Historically, the race was just about who could print the smallest transistor. Well, not anymore. Modern high-performance chips, especially for AI, increasingly depend on advanced packaging. This is the critical convergence of logic, memory, and packaging into a single system. And this shift is huge because it creates a very realistic, highly strategic entry point for emerging players who might not be able to compete in leading-edge wafer fabrication just yet. Which brings us right to India. Let's zoom in on their starting position, because contrary to popular belief, they are not starting from scratch here. India actually already holds a massive piece of this puzzle. They have long been a global powerhouse for front-end semiconductor design and R&D. We are talking deep, pre-existing expertise in VLSI design, physical verification, AI hardware, and embedded systems. They have the engineering talent in spades. What they've historically been missing is the large-scale domestic manufacturing to actually match that front-end talent. So, with all this foundational talent and a huge new push from their government, a really logical question comes up. Is India's goal to immediately duplicate Taiwan's advanced ecosystem? Are they just trying to copy and paste TSMC overnight? The short answer? No way. India is not trying to replace Taiwan. Instead, what the India Semiconductor Mission outlines is a highly realistic strategy. They're using a blend of international partnerships to build out their own comprehensive, full-stack ecosystem. They're targeting design, fabrication, testing, packaging, the whole shebang. Because let's face it, building a fab without the local suppliers, the testing facilities, and the domestic customers doesn't give you an ecosystem. It just gives you an isolated factory. Let's move into our next section and look at exactly how India is bridging that gap with some truly massive physical infrastructure. The sheer scale of the investment happening right now is pretty staggering. Take a look at this. Over 91,000 crore rupees is being poured into India's first major commercial fab in Dholera, Gujarat. This is a huge partnership between Tata Electronics and Taiwan's PSMC. With a planned capacity of 50,000 wafer starts per month, this project isn't just about output. It gives India a critical training ground to develop process engineering, run complex fab operations, and master yield engineering. They are literally building the industrial muscle memory required to run a fab. What's brilliant here is the formula they're using to accelerate this growth. They are merging Indian capital with global technology, heavy government support, and an absolutely massive domestic market. They aren't trying to go it alone. Tata Electronics just signed an agreement with ASML for that Dholera fab. Micron is pouring over 22,000 crore rupees into a massive assembly and test facility. CG Power has teamed up with Japan's Renesas. By partnering with these established global heavyweights, India is executing the exact same formula that successfully built the world's other major semiconductor hubs. And crucially, they aren't dumping all this infrastructure into a single city. They are building for high resilience through geographic distribution. You've got the wafer fabs and OSAT facilities in Gujarat. Then you have a massive 27,000 crore rupee packaging hub being built by Tata in Assam. You've got ecosystems emerging in Uttar Pradesh and compound tech taking root in Odisha. This kind of geographic diversification is absolutely vital for building a strong national network rather than a fragile single-point cluster. All right, moving to our final section, let's look at the strategic master plan that's actually guiding all of this massive growth. When you map it out, India's trajectory follows a highly calculated 6-phase strategy for the next 10 to 20 years. They start with what they already know best. Phase 1 is chip design. Phase 2 leverages those new infrastructure projects for packaging and testing. Phase 3 steps into mature fabrication, exactly like the Dholera fab. Then, Phase 4 scales up into compound tech, like silicon carbide. Phase 5 focuses on building out the underlying materials and homegrown IP. And only then, in Phase 6, do they plan to tackle the ultra-complex, advanced logic manufacturing. It is an incredibly logical, step-by-step roadmap. Now, let's take a second to ground the hype, because it is vital to acknowledge what India still needs to relentlessly build over the next decade. Building a fab is really just step one. The domestic ecosystem is still quite weak when it comes to upstream materials, things like raw silicon wafers and specialty gases. They need massive developments in domestic equipment, and honestly, most importantly, they need a whole new generation of specialized talent. Process engineers, yield experts, and material scientists who know exactly how to operate inside a clean room. But addressing those exact gaps is the whole point of the India Semiconductor Mission 2.0. The ultimate structural transformation India is aiming for here isn't just about output. It's about moving from merely using global technology to becoming a primary developer of its own indigenous intellectual property. ISM 2.0 is laser-focused on supply chain resilience and full-stack design. It's about fundamentally owning the underlying technology, not just assembling parts for someone else. So I want to leave you with this thought today. The global chip industry is undergoing a massive structural shift. The old model was completely obsessed with maximum efficiency and deep geographic concentration, but today, the emerging model demands efficiency paired with resilience, technology sovereignty, and geographic diversification. With their incredible pre-existing engineering talent, a booming domestic market, and deep partnerships with global heavyweights, India is decisively moving toward becoming a genuine end-to-end manufacturing ecosystem. As the world desperately seeks geographic resilience, is India perfectly positioned to become the indispensable tech hub of the future? Thanks so much for joining me on this explainer, and definitely keep your eyes on this space. The next decade of silicon is going to be wild.